before you were born, and will be gone long before the planet dies.
And then you see something that shouldn't be there. Something so powerful that even light cannot escape. You have just encountered
The core collapses. If massive enough, it keeps crushing matter down until it forms a black hole.
A black hole isn't simply a hole in space. It is a region where gravity becomes so powerful that the escape speed becomes greater than the speed of light. And once something crosses the point of no return, there is no way back. But what exactly is a black hole? Surprisingly, it isn't a giant cosmic vacuum cleaner. It's a region of spacetime where gravity has become extraordinarily strong. According to Einstein's theory of relativity, massive objects bend spacetime, and a black hole bends it to an extreme. Imagine space itself being pulled into a cosmic valley.
Light normally travels at nearly 300,000 kilometers every second, but near a black hole, gravity can bend its path. And beyond the event horizon, even light has nowhere to go. But where do black holes come from? Some begin with something enormous, a massive star. For millions of years, the star fights a constant battle. Gravity tries to crush the star. Fusion pushes outward. For most of the star's life, these two forces remain in balance. But eventually, the fuel begins to run out.
And then, the star's surface shivers, violence breaks. The gravity wins. The star begins collapsing faster and faster until the core can no longer resist. If the remaining core is massive enough, it keeps collapsing. More intensifies until space-time itself becomes trapped around it, and a black hole is born.
Now we reach the most famous feature of a black hole. It was approached just at the powerful line in advances, the event horizon.
The event horizon isn't a solid surface. You wouldn't crash into it. It's an invisible boundary, a point of no return. Cross it, and every possible path leads deeper inside.
Here, our normal understanding of space and time starts to become very strange. Because near a black hole, space and time themselves are affected.
Now imagine, you are the astronaut. You're drifting toward a black hole. At first, everything seems strangely calm, but as you get closer, the universe begins to look different. Stars stretch, light bends, and the black hole grows larger in front of you. Now imagine your friend is watching from far away. They see you approaching the event horizon, but something strange happens. To them, your motion appears to slow down. Even the light coming from you changes. It becomes stretched toward longer wavelength, redder and dimmer, until you become almost impossible to see. Your feet are closer to the black hole, so they feel a stronger gravitational pull. Your body begins to stretch, longer and longer.
Scientists actually have a name for this: spaghettification. Yes, the universe has a terrifying way of turning physics into spaghetti. But here's something surprising. Black holes themselves don't shine. So why can they appear so incredibly bright?
The answer is the material around them. Gas and dust spiral inward, moving at incredible speeds. Collisions and friction heat this material to millions of degrees. And even the light from this blazing material can be bent by the black hole. Light from behind can curve around it, creating an image that looks almost impossible.
For decades, the black holes were mostly mathematical predictions. We knew they should exist, but actually seeing one was another story. Then, scientists connected radio telescopes across the entire planet. Together, they created something comparable to a telescope the size of Earth. They pointed this global network toward a galaxy more than 50 million light years away, Messier 87. And at its center was a monster.
In 2019, humanity finally saw the shadow of a black hole. After decades of searching, we had our first glimpse of the darkness itself. But stellar black holes aren't the biggest ones. At the center of many galaxies, something far more enormous is hiding.
Our own galaxy has one. It's called Sagittarius A star. It sits roughly 26,000 light years away at the heart of the Milky Way.
These black holes can contain millions or even billions of times the mass of our sun. Some are so enormous, they can influence an entire galaxy.
But now, we reach the greatest mystery. what actually happens after you cross the event horizon?
Einstein's theory of relativity can describe the extreme gravity. Quantum physics describes the microscopic world. But inside a black hole, these two worlds collide.
And our current theories don't completely agree. Somewhere inside a black hole, our understanding of reality may no longer be enough.
Now imagine you throw a book into a black hole. The book contains information, every word, every image, every tiny detail, and then it disappeared. So where did that information go? Was it destroyed? Or is it somehow still encoded in the universe? This is the black hole information paradox.
Physicists have debated this question for decades, and the final answer could completely change our understanding of reality.
And here's another surprise. Black holes may not simply destroy things. They may also help shape the galaxies around them.
Some supermassive black holes launch enormous jets of particles, traveling at nearly the speed of light. These jets can stretch thousands of light years. The energy released by these monsters can influence enormous regions of space. So black holes may be destructive, but they may also be part of the machinery that shapes galaxies. So what have we learned? A black hole can be born from a dying star. It can bend space and time. It can trap light, and it can destroy anything that ventures too close.
But beyond that horizon lies a place we cannot directly see, a place where our best theories begin to fail. And that may be the most fascinating thing about black holes. Maybe one day we'll discover what lies beyond the darkness. Maybe we'll finally understand what happens inside. But for now, the universe keeps its deepest secrets hidden in the darkness. And perhaps that's exactly what makes black holes so terrifying. If you want to explore more of the universe's greatest mysteries, subscribe, because the next one might be even stranger.